No, I wish.
All right. So we have a bunch of people online. Do you want to introduce yourself real quick, just so people know who you are, and then I'll probably do about 10 minutes, just kind of showing some work I've been doing on Pipeline, and then you and I are just going to chat. I want to ask you about Istio and fabricate and Funktion and all the fun stuff you've been working with. I know you've been a big fan of the Netflix open source, and that was my background as well.
Yeah.
Which is why I keep bumping into you, and I always have 1,000 questions for you. So
awesome.
I have about 1,000 more. So
sounds good.
Yeah, man, go ahead.
Sure. So I'm Christian Posta. I am, I guess now a chief architect for cloud native application development at Red Hat, and I participate in a handful of interesting open source communities. I travel around mostly North America to help our Red Hat's enterprise customers understand what microservices is and what it really means to them, and how they would go about implementing that and getting some of the value out of doing that. And so I like to speak at conferences. I've written a book, and just keep busy.
Oh yeah, which book is it again? The microservices one?
Yeah, microservices for Java developers. Yeah, and I sort of take a hands-on approach to building services with 3 popular Java frameworks like Spring Boot, Drop Wizard, and Wildfly Swarm, and how to containerize them and run them in a cluster manager like Kubernetes.
Gotcha. And so what was life like before Kubernetes?
Oh, that's a good question. It was
and what did we use?
Well,
what did we do?
we hand built a lot of our own stuff, basically.
Yeah. Right.
Because we still had a lot of the same problems, but we needed
Totally.
to solve them somehow, and ended up building things that at least what we can say, at least in the fabricate community, we can say that what we built was not like Kubernetes, not as good as Kubernetes.
Mm-hmm. And then how about things like Mesos and stuff? Have you used those much, or is it?
I've not actually used Mesos. Yeah, I mean, I've talked with lots of people who have, but I've personally not used it in any non-trivial way, at least.
Mm-hmm. Gotcha. Yes, I know Netflix is using Mesos. A few other people, like the Twitters, and yes, I know places like Databricks where Mesos came out of the AmpLab project, which is where Spark came out of, the Berkeley AmpLab. So they didn't even use Mesos. In fact, they're on Kubernetes now, so it's kind of interesting.
Nice. Yeah.
Mm-hmm.
Yeah. So I've not specifically used it, but I, at least for the frameworks like Spark and some of those others that live in the big data space, they gravitated toward it. But
Mm-hmm.
I'm seeing lots of interest in running those same types of workloads on Kubernetes, and the community's coming around to help make that happen.
Cool. And so you have a pretty good blog too, right? From what I remember. How do I find that?
Yeah, that's just christianposta.com or blog.christianposta.com.
Yeah. And so I was going to ask you about some of the distributed tracing, because I know you've been working inside of Istio. Okay, so this is Christian's blog here, is really good. And then I think you guys can all see my screen, hopefully, right? Then,
I can see it.
Istio.io. So I first started bumping into you guys. So Pipeline, we are trying to bring the same kind of high availability and scalability and fault tolerance and fallbacks and circuit breakers and all these cool patterns that we use at like Netflix to serve up streams to people, and like video streams, and make sure the service was always available. We're trying to bring that to the machine learning AI world, right? And like we're not really seeing too much in that area. Most tools, right, like Databricks, most tools like Domino Data Labs, and some of these, right, like ML AI focused tools, typically their pipeline ends, their like machine learning pipelines end at training, and then from that point it's like, what do you do, right? So we're trying to go from the notebook, from Jupyter Notebook, which is what 95% of all data scientists seem to use in Python, and then like the ability to quickly push models out and do canary models, right? Like that was one of our very first conversations, I think, maybe a year and a half ago, something like that, right? When I was asking you, hey man, how do I do canary deploys with Kubernetes?
Mm-hmm.
And you walked me through it with the selectors and all that. One of the and so where was I going with that? It was, okay, so yeah, back to Istio here. Can you, I guess we're kind of flipping this around from the order I was going to do it, but I want to make sure that we get this stuff in. Can you just explain kind of high level, what is Istio?
Yeah, Istio is sort of a layer below our applications that build resilience and things like routing and control into the network below the application that allows us to do interesting things like the sort of deployments that you're talking about, traffic shaping and traffic management. We're able to build observability into that layer of networking that exists between the applications, and you can kind of think of it as a lower level networking substrate, but that deals with application level requests like HTTP requests and RPC calls, and not to the low levels of like the level 3, level 4 part of the networking stack, like just deals with packets and connections and that stuff. So it's a little bit higher level, but it is still sort of networking that allows us. It sort of opens up this new opportunity for building apps in a smart and resilient way, without having to jam a lot of that, because otherwise we would have to build a lot of that stuff into our applications themselves. And so that's why I love seeing new technologies that help solve some of the problems that we've always had in a bit of a more elegant way, sort of the way Kubernetes did for us. Like I think everyone had their own way of looking at infrastructure as a service and building cloud native applications on top of it. So Netflix had their entire stack. In the fabricate community, we did something similar. We we built a lot of the so-called runtimes and distributed configuration and leader election and all that stuff on top of Zookeeper, and did a lot of stuff in Java and that kind of thing. But Kubernetes model, more elegantly solved a lot of those deployment and management problems of our applications. And just the same way, I think Istio more elegantly solves some of the networking stuff we were trying to do in our applications, but now at a lower level. So now any application can take advantage of it.
Right. And so some of the cool things we did at Netflix were like this percentage-based traffic splitting, and oh yes, I know where. So there's that Netflix open source project Zuul, right? Zuul. And I was actually kind of shocked when I saw this Istio stuff. In fact, one of my buddies tipped me off and said, hey, you should probably check this out, since I know you're starting to work on traffic shifting, and specifically traffic shadowing is something that we're doing quite a bit of now.
Yeah.
Where we can push models out into sort of a silent canary or a shadowed canary mode. And so they're taking samples of live traffic, typically not like 100% of live traffic, but and sort of logging the inputs and then logging the predictions, and then we're comparing that to the current models that are out there serving. And so we're always kind of making relative, yes, is this new model like super far off the predictions of the existing model? What sort of tolerance are we capable of dealing with, and that kind of stuff. And so I was surprised to see Istio, because I know that you had done work with Zuul and getting Zuul into Fabricate, I believe, and or possibly Spring, or somewhere I kept seeing your name there. So yeah, can you talk about Zuul and how it sort of influenced maybe Istio?
Yeah, so I think Zool was the edge router, the ingress router that Netflix used to be able to finally control where requests went into their service, their services architecture. And you could do interesting things like service discovery and load balancing and dynamically insert rules and filters for being able to shift traffic between the services that ran in the back end. So you could do interesting things like A/B testing and some of the same things you're talking about, right? So send traffic off to maybe an ad hoc stage or a canary deployment style of deployment and test things out and see how things react and track data and get feedback from whether those changes that you're making are changes going in the right direction and so on. And so Istio does something similar. What I like about Istio is that it gives that same sort of precision and control to the traffic, but not just at the ingress level. We can do this now between any services that are talking to each other. So that becomes now you get not just the edge, but you get you get the edge and all of the pieces inside the services architecture, and
Right.
you can do interesting things with that.
Cool. And so this concept of kind of a service mesh has been mentioned, and like we've heard this term throughout the years, but it's starting to come back again, and it's typically in the context of Kubernetes and some of the new ingress things, or like capabilities. I guess, or like where do you guys fall in this service mesh?
So I guess technically Istio would be a service mesh. I personally am not totally a big fan of that because that's like you were hinting at there, that I feel like that term's been used or overused quite a bit. Because we even back in my days when we were building messaging brokers and that kind of stuff, getting full service mesh of brokers and messaging systems was similar terminology. I like to think of it as this is a application level network substrate, which doesn't roll off the tongue as nicely as service mesh, but it's sort of the nervous system. It's the tissue through which all of these interactions with our services happen. But yeah, technically, I mean, if we're talking about the modern day service mesh, then Istio is one of those.
Cool. And so I'm just checking out some of the features here. Rate limiting and request timeouts, and I believe the circuit breakers are built in here too, right?
Yep. So Istio uses or one of the things that I like about Istio is that it uses a service sidecar model to inject its proxies, so that the applications, the services themselves, aren't talking to each other; they're talking to their sidecars. And that diagram right there will illustrate that, where service A is co-deployed with a service proxy, the Istio proxy, and that is built on technology called the Envoy proxy, which came from Lyft, or comes from Lyft. It's an open source project from Lyft.
Right.
Yeah, and so Envoy is that proxy that gets co-located or co-deployed with the services. And now when the services talk to each other, they don't actually talk to each other directly. They talk through these proxies, and these proxies talk to each other. And so that's the mesh part of the description.
I see. And so this is where you would introduce either failures or latency, right? Like things like latency monkey, that kind of stuff. Like this is where you would do it.
Exactly. So it's sort of it's a point in the network communication that now gives us things like control. So like if we want to introduce latencies, if we're doing some sort of tests, or we're just doing chaos testing, it introduces a point of observability, so we can see the traffic that's going over the proxy here, and we can also do interesting things like control whether where we want to route the traffic. So maybe in this diagram we see A wants to talk to B in this particular service interaction, but maybe service B, maybe we deploy a new version of service B and we don't want it to talk to the old version, or we want a small percentage of traffic to go to the new version of service B. With this point of control in our communication, we can affect that change. We can make that change without the applications knowing anything about it. So these are transparent to the application and are able to inject this additional functionality, routing, control, observability, just by looking at the network traffic.
Okay, and then one thing I noticed too is that you guys support the new HTTP2, gRPC, protobuf, that kind of stuff, right? So it's not just limited to. Okay.
Yeah,
that's cool. That comes in handy for.
Moreover, I'd say that so the Envoy proxy is that proxy that we use, and Istio provides. You can see the control plane parts on top, but things are tightly integrated with each other, although not exclusive. So these proxies you can build new implementations of these proxies. Istio today runs on Kubernetes, but you can there's hooks and APIs to be able to run it on other platforms like Mesos and Cloud Foundry and those. And I think people are working on making that happen. But yeah, so these are but Envoy itself is a level 4 proxy, level 3, level 4 proxy, as well as higher level L7 HTTP and gRPC type proxy. But what's interesting to me is that since Envoy is an L3, L4 proxy, so we can basically write filters on top of byte streams, we can write smart filters on top of any protocol. I think the Lyft folks have something for Mongo and Cassandra. I would love to see something for Kafka and some other message brokers. But you can build these smart filters on top of the byte stream that's flowing through these proxies. So I expect to see that to continue to evolve.
Cool. Yeah, speaking of Lyft, I've been hearing more and more about their tech. They're like you don't really see them at too many conferences and things like that, but yeah, you start seeing some stuff creeping out through the open source. And I've got a buddy that has an offer in hand, and he's was talking to me about it yesterday, and it sounds really cool. Yeah, they're doing a lot of cool stuff there, huh?
Yeah, I think so. Envoy came from Lyft, and I think I just saw that Lyft is going to move their application deployments to Kubernetes. And so I'm sure there's going to be a lot of cool stuff coming out from them.
So one area Pipeline's really heavy into is like metrics, and yes, every step of the prediction we're actually logging, like time it takes to convert for like JSON into a NumPy array, or to pandas, or to a TensorFlow tensor, whatever, and then the actual time to predict, and then the time to go the other way and convert the tensor back in to the JSON response. So we have tons of metrics. We're constantly comparing like the current model with the new model, or multiple models that you're experimenting with, maybe one in Scikit, one in TensorFlow, one in Spark, or one just kind of raw Python or raw C++. So people are like pushing these out just to see. And yes, I know you guys are very heavy on the metrics as well too. So there's this like Zipkin stuff, which I know that you're pretty like active with. And then yeah, what else do you guys got going on here for metrics?
So the Envoy proxy, the Istio proxy that gets co-located with each service, can pull lots of different metrics, like number of requests that have come through, or the time it's taking for requests to complete, or the number of times you hit this at HTTP level, maybe the number of times you hit 500 error codes, or the number of times you're
Mm-hmm.
invoking circuit breaking. And then it can also send, and it can help propagate tracing context through, at least in HTTP, some of the headers, some of the Zipkin headers that we can automatically either inject if it's at the ingress level, or at least propagate through the system and send those spans to a tracing backend. So there's lots of things that we can collect, and the way Istio works is it's actually able to basically feed those metrics up through the mixer component. So Istio has a component, part of the control plane, that allows you to set policies and security, access control type policies, but it's also responsible for taking some of that data from the proxies that are deployed out into the applications and aggregating and collating that the metrics that can be streamed back, and then putting them into their proper backend engines. So, for example, for number of requests, queries per second, transactions per second, that kind of thing, we can pull that sort of time series data from the services, and through the mixer we can tell the mixer, hey, when you get this information, plug it into the metrics backend that we already have, like a Prometheus or something. So we have visibility of the data, and we can actually direct the data to appropriate backends. So the mixer doesn't actually store any of that stuff. It doesn't try to replace any of your observability tools, but it is sort of the integration point through which you can plug in to your existing backend tools.
Got it. And so these dashboards look like a lot of Grafana, and like by default, does it use Prometheus, or what's the, or like out of the box? How do I just get this?
Yeah, there are out of the box plugins, mixer plugins for Prometheus. But like I said, it is built on a plugin model. The mixer is written in Golang, so you can build any. I mean, I just like for the Envoy filters, I do expect to see as Istio becomes starts to head toward a 1.0 GA, and as it starts to pick up more steam in the community, I would expect to see more of these native plugins for the mixer to be able to plug in things like metrics collections, distributed tracing information, things like API management, and all these other repositories where we may want to declare policies.
Cool. Yes, I just noticed that the Weaveworks guys seem to have picked up Istio, huh? Have you worked with them at all? Did you know how they're using
honestly, no, I haven't. I haven't looked at. I know they do a lot of interesting stuff in the networking space. So I would be very curious to see what they're doing. It's just sort of a time, only so much time in the day problem. Right.
And so when I describe Istio to people, especially like my old Netflix buddies, they get it. There's certain people I talk to that are more opsy that are just like, why don't you just do all this within Nginx or within, like Apache rewrites and or like that kind of stuff. And what's the argument there, right? Like, how do you?
Yeah, I guess the thought is that, Nginx is awesome at what it does. Things like HTTP is awesome at what it does. Apache, I mean, you can get this proliferation of different tools that, each have their own intricacies for running them at scale, for configuring them, and so on. And I think from an ops perspective, I think the argument goes something like, this is just one thing versus like 3-4 different things that you have to operate and try to maintain configuration and consistency between. This is one thing that can fit in all of those use cases, and it just becomes easier to reason about and operate at scale.
Cool. Yeah, right. Like one thing Pipeline had a problem with sort of early on, and I guess we still kind of have this problem, is we go to a customer, sit down, and we start talking about Kubernetes and all this cool stuff. And, the ops guys around the corner can hear us talking and comes running up and says, we don't want to deal with like Kubernetes. It's too complex. Why are we doing this? Right, like they might already have Yarn, they might already have Mesos, or they just don't want to deal with this kind of thing, right? So, like one thing we've been trying to shoot kind of more fine-grained or stick with just Docker images, but then very quickly, now I have a single Docker image that has everything on it.
Right.
Like it's got Spark runtime, it's got TensorFlow, it's got which is nice for demo purposes, but so I guess this is like sort of a comment, but also a question at the same time. Like, how do you, for us, we're now kind of de-emphasizing the actual infrastructure, right? That like our tools use, because like the problem is if we don't use something like Kubernetes and then Istio and have like this ability to do these canaries, it sort of cripples the entire offering, right?
Yeah.
And if we just have a Docker image and we're we are just configuring Nginx, we're like sort of limited. And so instead of that, like we're sort of doing it like Databricks does, for example, like when they try to convince people to use their software, they don't talk about how, the stuff is being orchestrated, right? And in fact, they didn't even use like Kubernetes or Mesos or anything before. They had their own scheduler, but they never talked about it because it wasn't important. It was just, here's our offering and install this in your account and go. But so I guess the question is, have you seen this? I mean, are certain people kind of like reluctant? I know you guys do a lot with Kubernetes. Do you have to, kind of dance around that or work with the ops guys, or what's your approach there?
Yeah. I think in the longer term, so the higher value that we're able to build on top of, so some of the things you're talking about, like building the resilience, building the traffic shaping, being able to do more complex deployments, regardless of what the infrastructure is underneath. I think with Istio, since Istio is not specifically tied to Kubernetes, and the goal is to have Istio provide this functionality across platforms, Mesos, Cloud Foundry, Kubernetes, and traditional VMs. So we get this heterogeneous deployment infrastructure, but we are maintaining consistency around the resilience and the control of how the applications are talking with each other. So I think as we go down that path, I think for some of those discussions, we'll be able to alleviate some of that stuff. Now, for the present day discussions, so at Red Hat, where I work, we have a kind of a distribution of Kubernetes that we've built our paths on top of, OpenShift on top of, and I think we probably face similar scenarios where we've built a lot of higher value tooling and capability on top of Kubernetes, but Kubernetes is the core. And when we talk with folks, so I mean the sort of folks that we're talking with at the enterprise level are a little bit behind possibly some of the customers that you might be talking with. So they didn't really sink a ton of investment into Mesos or some of these other orchestrators. So we're in a position, and luckily the things like, so we believe that Kubernetes is the best place to run these types of apps. We're also happy to see that a lot of other people think that as well. So I think the momentum in the Kubernetes community has been advantageous for that. But yeah, I mean, the customers that we do talk with that, like for example, that do have Mesos or do have another platform, then the discussions become a little bit tricky.
Yeah, and I mean, from a product deployment, thinking of this, right, like kind of a closed, like packaging or like prepackaged software, right? Like, I guess the idea is that they shouldn't even have to know that it's Kubernetes. Like, it doesn't necessarily have to mold into their current infrastructure, right? So just to kind of keep the touch points low and that kind of thing.
Exactly. Just say, hey, it's a cluster. Just give me a bunch of
exactly
machines, and we'll run our product. Yep.
Totally. Okay. Let's see. I think I had. And so, can you? I'm just like preparing for the demo here in a sec here.
Yep.
Can you talk a little bit about fabricate and function? Are the other two? So let me pull them up here.
Yeah. So fabricate has been an upstream community for Red Hat. So, and upstream is, so everything at Red Hat is open source. Everything's done in open source communities, and we either bring those communities together or bring parts of those communities into our products that we then support for long-term support. And all of those are open source as well. But so fabricate for a long while now has been the upstream open source community for some of our products at Red Hat, like our integration platform, like some pieces have been folded into OpenShift, our PaaS, and we've sort of used fabricate as a way to basically go fast and try to see what works, what can we do, what sort of tooling is needed, and it provides value to people who are trying to build and run microservices on top of Kubernetes. And so we've come up with things like kubeflix. So we had lots of folks who were interested in running NetflixOSS on top of Kubernetes.
Yes.
We've had CI/CD is probably the single biggest prerequisite to run microservices anywhere, and then other tooling. So we have a lot of customers who develop in the Java space, and so creating tooling to make their lives a little easier, and so on. So there's lots of these spikes of value that we bring to those in the Kubernetes community, and then Function we saw as an opportunity to build a Kubernetes native serverless framework, using some of the technology that we have already had and leveraged to build high value functionality on top of Kubernetes already. So Function is a fully, it's built on top of Kubernetes for Kubernetes and tries to be as Kubernetes native as possible for building serverless style applications.
Okay, and so Function is like Lambda, is like the Amazon Lambda, right?
Right. Yep. And we can create flows. So all of the applications run in Docker containers, and we can, I think it's Node.js and any of the JVM languages, maybe one other language that we support right now, but we don't see languages as the sort of the hard problem. Maybe Java, because there's some optimizations that we're going to have to do for Java, because everything running in a Docker container, the hard parts are how do we source the events that will cause our functions to trigger? How do we get the components to talk to each other in the different functions, and how do we establish flows between these functions? And then, of course, there's going to be optimizations that we'll need to do to make the UI and UX nice on Kubernetes, especially spinning up Docker containers, and how do we get density and some of that stuff. But I think right now we've been focused on how we get event triggers and how the services interact with each other, and how you define flows between those functions. And what's really cool is that so one of the main developers, developer who kicked us off and kicked off a lot of this stuff in the Fabricate community, James Strachan, who also wrote, he's been writing open source projects for decades. He also wrote a project called, he wrote the Groovy, he helped write the Groovy programming language, but he also wrote a integration library called Apache Camel. And Apache Camel has been used for a long while now to integrate disparate systems, and those could be talking over all lots of different protocols, for anything from file systems to databases to SaaS systems to messaging queues or any systems. About 200 different connectors in the Apache Camel community. And so what we've done is, and Camel is built on a sort of event or a reactive or rather an event-driven approach already. So we can do polling or we can do event triggers. And so what we thought would be kind of cool is to bring the power, instead of trying to rewrite all of these connectors to all of the different backend systems where we might source events. We thought it would be kind of cool to just leverage that existing library to be able to do that. There's already 200 connectors for talking to different systems. And so Function under the covers, although the Function developer knows nothing of it, they select the trigger sources and how their functions should be invoked. But under the covers, we're able to leverage a lot of the value that we've created in the Apache Camel community to do that event triggering.
Sweet. Yes, I remember that actually when I first started looking. Yes, I thought that was pretty clever that you guys. Yeah, I didn't realize James was the guy behind this.
Yep. James Strachan. Cool. Serial project creator.
Yes, I can never spell his last name right. James
S-T-R.
This guy, right? Yeah.
Yep.
Cool. And so how do people get a hold of you guys, if they have questions about Fabricate or Function or rather Istio or, Zipkin, things like that?
So for the things that we're doing on Function and the Fabricate community, I would say go to fabricate.io or at fabricate.io on Twitter. And there's IRC, so in the free node IRC. So if you go to fabricate.io, you'll find and click on the community sections. We have a Slack and IRC and all that stuff. For Istio, I'd say go to istio.io, and we've got a Slack and Google Groups. Probably Google Groups is probably a good place to ask questions and get started. And there's also at Istio Mesh, I believe, is the Twitter handle.
Okay, follow us on Twitter. Okay, yeah, this one here, the Istio users, Istio dev. Are these Google Groups or are these
Those
Apache?
are Google Groups. Yep, Google Groups. Nope.
Okay.
Fabricate.io and Istio.io are non-Apache groups right now.
Okay. And yeah, how about Stack Overflow? Like, are people paying attention to that channel?
Yes, definitely. Yep. I mean, I think every project should pay attention to that. So.
Yeah, it's funny because at Databricks, like there was always kind of a question: do we pay attention there? Like the Apache folks really want you to be paying attention to, right, like the user email list, and which is very overwhelming trying to pay attention to all those. That's one thing I've noticed about TensorFlow, the Google community. They have people on call, pretty much 24/7 throughout the world on Stack Overflow, which is really nice. They don't have to deal with some of the Apache things like that. So
yeah. I mean, the idea at Apache is it doesn't happen on the project unless it happens on their mailing list. But the reality is, the users tend to use whatever they seem to get the most value out of, and sometimes signing up for the Apache mailing list isn't that low of a resistance for them, so they go off to other things. So I absolutely think keeping an eye on the community in Apache, if it's an Apache community, but the community at large, even outside, is important.
Cool. Okay, so we have about 15 minutes. I thought I had one more question. Yeah, so I guess kind of future looking, right? Like, where do you think things are going to end up? Like, I think Kubernetes is, making a strong push. I see a lot of people adopting it. It's a little bit tricky to get started, but things just kind of work, right? Like after you get over, the initial day or two of the terms, but like beyond just kind of like orchestration stuff? Like, where do you think a lot of stuff is going? Is it going function, like, lambda like? Is it?
Yeah. Well, first of all, I think there's still, and I think the Kubernetes community appreciates this, that there's still a lot to be done to improve the developer experience for getting started with Kubernetes and actually installing a live cluster and operating the cluster. But what I like is that Kubernetes is focused on solving those core problems of cluster management and some of the UI and UX behind that. But they're not trying to take over the world. They're not trying to put every single piece of functionality into their project. And that I've seen in the past, that does tend to derail or bloat projects when they find a sweet spot where they're really good at, and then they try to do everything. Kubernetes seems to be staying in that one spot. Now, I'm excited about the things we're going to be able to build on top of Kubernetes, like the pipeline.io stuff, and the stuff that we're doing in Fabricate or the OpenShift communities. And now we see Istio, so this new way of managing a cluster on Kubernetes or any platform that we can build on top of these pieces of functionality. And I would say serverless is another one of those. I think the innovation curve, or how we start building out the pieces, and those seem pretty awesome at first because they're innovative, and then they slowly become, everybody has that, and then they slowly become commodity, and then a new wave of innovation happens. I think those loops, those innovation curves or cycles are happening a lot faster now. And as much as we like to sit around and predict what's going to happen, I think the space is continuously evolving so quickly that I don't know. I could not have predicted Istio coming up 2 years ago. So I don't know. I think it's a pretty exciting time.
Yeah, I mean, I was just dusting off all the old Zool docs and Zool code, and just starting to ramp up on a lot of this traffic shifting and traffic shadowing, and I was so happy to see Istio. Yeah. And so so for things like MiniCube, right? So this is one of the reasons I think Kubernetes is starting to gain a lot of popularity. Is it's so easy to get MiniCube running on your local laptop. You can actually recreate these, and I've been looking into ways to even distribute Pipeline as a MiniCube, sort of bundle that would essentially be just like a single Docker image. Hasn't been that smooth, but that's kind of my goal, is to keep the separate, or this sort of cluster idea, but just keep a smaller sort of packaging thing to give to people. And so does Istio work with MiniCube, and does Fabricate work with MiniCube?
Yep, Istio works great. Istio works great with MiniCube. Fabricate. So I started to say Fabricate has always been upstream for some of our products at Red Hat. The big flagship product that it is now the full upstream for is called OpenShift.io. So if you go to OpenShift.io, it's not, it might just be developer preview right now, but it's going to be a full top developer stack for building services on top of OpenShift. And so that means things like bootstrapping your project, creating your project through templates and wizards and that kind of stuff, but then also setting up your CI/CD engine, similar to how Fabricate in the community has been doing for the last 1.5 years or 2 years. But then also tying in things like CodeEnvy for being able to not just bootstrap your project, but bootstrap your workspace and tie it into Git or GitHub, or and being able to do your coding right from the browser in CodeEnvy, sort of an Eclipse-looking browser IDE. Nice. And then tie that and the CI/CD into a project out of Fabricate that we're using to track, basically track hypotheses about what changes would impact our services or our users, and tie that and the metrics from those changes back into this hypotheses engine. So all of that stuff will be available. I think you can go there right now and sign up for developer preview, but it's continuing to evolve. So Fabricate.io is the upstream for this OpenShift.io.
Got it. Okay. And then one thing about the CI/CD stuff, yeah, this is the question I forgot to ask. So when I first started talking to you about Fabricate, like you guys had your own Jenkins plugins and right, like have you guys moved over to the like Jenkins Pipeline plugin, or like do you still maintain both? Or
Yeah, I guess thinking way back, yeah, we did end up using an interesting combination of Jenkins jobs DSL, and a bunch of other stuff. But no, everything's moved over to the Jenkins pipeline and Jenkins 2.0, and all of the, a lot of the work that we were doing around getting Jenkins and the Jenkins pipeline to work nicely in Kubernetes, we've donated all that to the Jenkins community.
Gotcha.
And so most of that, now if you go to the github.com/fabricate.io, there's a couple of interesting repos in there. And I think if you've been doing the pipeline stuff, yeah, if you go in here and let's see, where is it? Let's see, if you just type pipeline into the search repository there, I can never remember exactly which one, and then click on Fabricate Pipeline Library. Okay, yeah, this one. So this one has basically a reusable library of commands and functions that you can use inside of your Jenkins pipeline DSL. So you don't have to, and since you're able to pull these in, you don't have to continue constantly. Your DSL becomes much more terse. You can see exactly what the pipelines are, and without getting distracted about, oh well, I'm doing a Git tag here, and I'm trying to push back to Git, or I'm trying to send this up to an artifact repo, or I'm trying to do a stage or whatever. So like you get a lot of reuse out of this library for building up your pipelines as well. So all of the underlying core tech we've tried to offload or contribute to the proper communities where we think they'd get the most attention. And then for pipeline specific stuff, we still maintain this library of reusable functions that we can use in a CI/CD pipeline using Jenkins Pipeline.
And does Jenkins Pipeline support canaries as kind of a first-class citizen, or like that's why you guys have it in here?
Well, Jenkins Pipeline is sort of a generic CI/CD system.
Right.
So depending, and you don't have, Jenkins runs nicely on Kubernetes now, but you don't have to run it on Kubernetes, and you may have all kinds of different ways of doing canary releases. But so Kubernetes does, and through these library functions, I think there is a set of functions. Here's you can see Maven canary release toward the middle there. So that might be a Maven specific thing, but we can rewrite these or create these reusable functions that we can use inside of our pipeline to be able to do things like canary releases on top of whatever infrastructure we're actually running on.
Right. Yes, it's funny because I was at first, like when I was I sat down to architect this whole like sort of canary release thing, and I started looking at like Airflow, and I was pretty resistant on going towards Jenkins just because I felt like it was kind of big and bloated and crusty, and then I started finding myself basically rewriting a lot of what was in Jenkins, inside of Airflow, and it was just silly. I was like, why am I fighting this? There's so many plugins here, and I was trying to stay away from a Java solution because when you talk to these data science shops, they don't really like Java, but when you talk to these data science shops, they're using Jenkins anyway for a lot of their CI/CD, even for Python code and for their Docker builds and Kubernetes pushes and stuff. So I scrapped all that crazy new age thinking and back to basics, back to the good stuff.
Yeah, and we sort of went through a few of those iterations as well, and we just saw the overwhelming community in Jenkins, all the plugins that they have. It is fairly ubiquitous, at least for CI. So we saw that maybe there was an evolution for people to take it up for CD, and now Jenkins 2.0 has become basically focused on CD. So I think Jenkins has a lot of momentum in that area.
Yeah, I mean things like security. I just didn't feel like rewriting all that stuff, just to stick with an all Python solution. But how much Python do you do these days? Are you still mostly Java or Scala,
Python,
Go?
I guess I bounce around quite a bit. I guess I haven't done too much Python recently, but Python is one of my favorite languages. So
Mhm.
chances I do get, and I do enjoy it. But yeah, I would say Go or Java. Yeah, those two.
And so to do any kind of Kubernetes development, do you have to like be a Go, coder, or is it pretty, it seems like a lot of the newer Kubernetes, like operators and things like that. And I think there's a new Kubernetes service API or something that you can plug into the API server, right? Like your own APIs,
Yeah.
but like that has to be Go, right?
Yeah, so Golang for that that level of infrastructure, Kubernetes, Docker. I think the Hashi folks are all Golang, and I think everybody's for infrastructure style code. I would say Golang is sort of the default now. But then there are things like, so I mentioned the Envoy proxy from Lyft. Those are that's infrastructure code as well, but that infrastructure is probably a little more specific to a particular set of functionality that it's trying to do that. That's written in C++. So I think there's still going to be pockets and areas where C++ is absolutely the right approach, but I think on across the board, I'm seeing Golang as the default for these types of infrastructure.
Yeah, that's interesting. I mean, Go is known for its concurrency and things like that. Like, does that stuff come into play here, or if I'm doing? Yeah. I mean, I guess it would, right? Like,
yeah.
I guess there's kind of scripting infrastructure, and then there's like the hardcore, has to be thread safe sort of infrastructure. Yeah.
Yeah. On the other hand, I mean, you look at companies like, is it Yelp that have done a lot of their infrastructure and their high level infrastructure in Python. So,
right.
So yeah, I guess it depends on what you're comfortable with. But yeah, so Envoy here that you're looking at is written in C++ because they wanted super high performance and determinism when they're actually running. They wanted to. They don't want to, because they're in the request path, so they can don't want to introduce a lot of overhead. But on the other hand, large-scale deployment managers, cluster managers like Nomad and Kubernetes, and these are written in Go. But then, on top, the stuff that you build on top, I think that can be in any language.
Cool. All right, Christian. I think I'm done grilling you.
Yeah, that's good.
So yes, I appreciate it. If you want to hang out, there's about 3 minutes left here. I'm just going to show a quick demo of kind of the latest. So, all right, guys, hang in there. Let me show you what's going on here. So where am I? All right, so this is a demo. The context here is I've got some TensorFlow code that I want to train and then at some point deploy. And so I'm actually doing both of these steps inside. I'm going to package up one Docker image that contains the training code, and it's going to train itself and then serve itself on a port. So the thinking here too is that because I'm doing this all locally, because I'm doing this within Docker, I know that the exact Docker image that gets pushed out to production is the same one that I'm working with the same Python libraries, the same like pip installs and the conda installs and all that kind of stuff. So, so just to kind of show you, there's nothing up my sleeve here. What we're doing, here's a sample. Of course, we're using MNIST. Let me show you guys the code /train. So this is adapted from the TensorFlow example, MNIST, and we're passing in learning rate, passing in batch size. There's this sort of prepare phase, which is going to pull the data down to be used for training. There's a validation phase, and then there's a serving phase, essentially. So we're going to do all this. This on the right here is kind of what I'm going to be showing you guys here. So, okay, so let's just do this. Now, what I have here is a Docker image that contains the TensorFlow runtime. And what it's doing is it's slurping in the model that I'm passing in right here. So that's going to actually slurp in that like training code that I showed you guys. And so let's do it here, PIO model. Oh, so I've got this command line, you know, if you do pip install PIO -CLI, you can do this, but it'll be PIO model build. So here, the term model build means take my model that right now is just code, is just Python code, and build it into this Docker image, this sort of self-contained executable, right? And at first, I was just packaging up the trained model, and then I realized I could also actually really package up and do the training, and then really have it serve itself all at the same time. So I'll explain why you would do this here in a sec. It's essentially, so when you're doing model training, you have 20% of the data you would hold out, right? And then you would train the model on that like 80% that's left over. Then you would then take the 20% that you've held out and run it through the model to validate. And so this is the sort of validation phase. Now this is fine for, right, like this is how people think today, and then they push the model out into the real world, and this, could be, for example, fraud detection, could be marking every transaction fraud, right? And so what people want to do is extend this validation phase out into production, right? So this model, it's not truly validated until it's like sitting alongside the existing model, and then you could see how these two models compare on live traffic. So that's the use case here. Model type is TensorFlow. Model name equals mnist. Okay, let me just take a look at that. All right, I have to, the bottom of my screen is a little bit cut off because of Zoom. So this is the command I'm running. So this is actually going to build the Docker image and slurp in the model TensorFlow and mnist. Right now, it's just hard-coded to look in a samples directory, which is that samples directory right there. There's a samples directory here, and that has TensorFlow and then the mnist model there. That was what I was showing you guys before. Okay, so back up here. So this Docker image is essentially useless unless I give it the model type and the model name to slurp in. And now I'm going to do model start. Also, this works on CPU and GPU. Oh, I already had one running here. So let me stop that. Okay, start it. You can also do logs. So now this is all running locally. This is on my laptop. So here it's actually training itself. I don't have a GPU locally, so it's throwing this warning. It's not going to collect any CPU stats, but what's cool is it'll actually show during training the CPU stats, right? Like CPU load, CPU memory. If you're on a GPU, it'll show those as well. So, right, like data scientists can actually see this stuff, right? Like they might not care, but if they do see a relative spike from the previous model that they're training, then they can at least mark it and then take it for further investigation. Okay, so the end of this, don't worry about that error, that one down there, that's fine. All right, so let's take a look. So this is the model that we just trained, and we did a little validation step here. So we've got, right, like again, this is all kind of static data, batch data that we've trained. We took 80%, we trained it, then we validated on 20%. Here's some of the CPU stats. Some of these are a bit raw. This is the fact that I'm running inside of Docker, and some of the CPU stats aren't totally accurate. So working through some of those. There's no GPU. And then if I did multiple runs, so here I used a learning rate of 0.05. I can actually tell it to, oh, it's showing the TensorFlow version, which is the latest, 121, which just dropped, I think, a few days ago. How much RAM I've allocated this Docker image, 2 gigs, and how many cores. And here I can actually, if I had multiple runs, like one with a learning rate of 0.05 and one with a learning rate of 0.025, I could actually compare them. Didn't do that here. Also, I can bust into TensorBoard. So like a lot of you guys might be familiar with TensorBoard. We can actually look and see some of the same stats. So bias loss, here's our loss. This hopefully is going towards 0. Yes, it is. Also, TensorBoard gives us a look at the images that we trained with. So that's kind of cool. Anything /train was training, anything /validation was the 20% held out. We can look at the graph of our model here. Hopefully, what happened here. Number 1, boom. Hit the screen. Okay, slight bug there. Let's look at our distributions here. So that's our validation. Here's our training. And we can look at the fun histograms. Everyone loves a good histogram. Okay, so what this is doing is this is augmenting the existing TensorBoard metrics that are maintained during training, and sort of gives you a side-by-side comparison. Now, the next step is going to be incorporating the actual runtime metrics. So let me show you a quick thing there. So we're in, so this is now Grafana, and during, oh, and so I actually didn't complete the end-to-end here. There's a predict, PIO model predicts. And inside of this samples, TensorFlow, MNIST, there's this data directory that has a sample test request, and this is a sample image. Oops. So this is, you know, the 28 by 28 matrix and the, you know, grayscale values here. And so that's what we're going to use here. If we do PIO model-predict, it's already set up. If we look at the configuration for PIO, I've already got it set for model test request path, so I don't have to pass it, but I certainly could pass it. PIO model predict. I'll do it just to tie this together. Oops. So this is passing in what would normally come from like a web request or through a Kafka stream or through Spark streaming, something like that, right? So this is using localhost. The first invocation is pretty slow just because it kind of has to wake up TensorFlow serving and that kind of thing. So here we're actually making predictions. I've got this mode turned on where we can actually do like a little mini load test right from the command line. So this is hitting local, right? So what this is doing is giving me the ability to, if I've trained a super deep model of 50 layers deep, which I have super great accuracy, right? But all of a sudden, my local latency goes up, you know, from here it's 20 milliseconds or like 30 milliseconds up to 300 milliseconds. This is probably something I might not want to right, like bring out to production. Or if I do, I need to make sure that my timeouts from like any like devices that might be calling in, right, that those client teams know that this model is going to take 300 milliseconds, something like that. Or what you could do is deploy it in this sort of silent like canary mode, which will get traffic, but isn't necessarily going to fail, or is definitely not going to fail client calls because it's just sort of getting shadow traffic from the actual current model servers. So real quick, and you know, this is going to get integrated better into this dashboard here. So think of, you know, this is kind of the like offline training metrics, right? Like validation accuracy, training accuracy. Think of there being more columns here for sort of the current latency, right? Like the request latency. Yes, how long did it take to actually process? And because of the way that we're actually breaking down, so let me show you guys. We have 3 different monitors. One is, so I had mentioned earlier on the call talking with Christian here that we're actually monitoring how long does it take to go from JSON into the TensorFlow tensor, right? So there's a conversion there. So that we want to actually track separate. And then there's the actual prediction time. And then there's the other way, going from the NumPy array back into JSON. So all of that gets wired up here. It's just nice Python with scope. These monitors take care of the rest. They know the name of the model. They know the phase. And all of this ends up going to Grafana. And like I said, this will get pulled into the same dashboard at some point. And boom, this is localhost and it's direct. So this is just Grafana sitting on top of Prometheus. Prometheus is the data metrics collector. And let's see, we're going to do a new dashboard, got a new graph here. We're going to call this requests per second, or sorry, this is just total requests, total num. And then for here, we can do HTTP request total. And we're going to look at the last 5 minutes just to make it sure it's current. And you can see the 500 right there. So if I did this, so this is live. So, you know, like, so just imagine having counters here. The other metrics we have, we add a query. We can look at the, so there's a counter for the exceptions. There's metrics around the like prediction itself, and the transform request, and the transform response. So like imagine seeing those three right like alongside, and you're probably just getting updated sort of real time as that canary is out there live taking traffic. This is very useful, and then you can actually compare if you have multiple experiments out there, multiple models that have been trained differently. Maybe have right like deeper like networks. Maybe you have scikit model out there, not TensorFlow. Maybe you have a Spark model out there, right? Like these would all show up here, and you can compare them side by side. So that's the demo there. I think we're about 10 minutes over, so I'm going to let you guys go. Yeah, Christian, are you still on the line?
Yeah, I am.
Thank you so much. Yeah, thanks, man. Thanks for taking time out of your vacay there.
Yeah, my pleasure. Thank you so much for having me. It was a good chat.
All right. Sweet, man. Yes, I'll talk and see you soon, buddy.
Sounds good, man. See you.
All right. Bye, everyone.